Now that we've talked a little bit about moles and the kinetic molecular theory, let's put everything together. And we're going to interpret the kinetic molecular theory. Okay, so this is going to go into the module 2.1.2.1. So let's talk about some other equations that you can use that are kind of based on or derived from this kinetic molecular theory of gases. Okay, and so one thing that is pretty common is we can figure out what the molar mass or molecular weight of a gas is going to be. Okay, and so here's how we're going to do this. We know from the ideal gas law that PV equals nRT, right? If I multiply the pressure by the volume, I get number of moles times this constant R times the temperature T. If I rearrange this to solve for the number of moles, N, I get that N is equal to PV divided by RT. But I also know that number of moles is simply the mass divided by the molar mass. So since they both equal number of moles, I can set these two expressions equal to each other. So that gives me PV over RT is equal to the mass divided by the molar mass. Now all I have to do is rearrange and solve for big M, which is the molar mass. Okay, and so capital M, molar mass, is equal to the small mass, the actual mass of something, little m, times this gas constant R, times temperature in Kelvin, divided by pressure and volume. Okay, so when I use this equation, I have to be careful with the units. Okay, molar mass is typically in grams per mole. Okay, little m, mass, is usually grams. Okay, R is going to be 0.0821 liter atmosphere per mole Kelvin. Temperature is going to have to be in Kelvin. Pressure is going to have to be in atmospheres. And volume is going to have to be in liters. Here's another application of the ideal gas law. Instead of finding the molar mass of a gas, we can actually use it to find the density of a gas. Okay, and so let's rearrange things a little bit more and solve for density instead. Okay, so I know that density is equal to mass divided by volume. And so if I start with the ideal gas law again, PV equals nRT, I can solve this for volume. V is nRT over P. So now I can take this expression for volume and shove it in here. Okay, and so the density is going to be the mass divided by this whole quantity, nRT over P. And then I can combine this with another expression that we used earlier, right? The number of moles is the mass divided by the molar mass, and do some algebra, okay? So basically rearrange some of the variables around. And I wind up with this expression here. Okay, the density is equal to the molar mass multiplied by the pressure divided by RT. Okay, same restrictions as before. I have to make sure that my units are consistent, okay? So here, once again, molar mass is going to be in grams per mole. Pressure is probably going to be in atmospheres. Okay, R is 0.0821 liter atmosphere per mole Kelvin. Temperature is going to have to be in Kelvin, absolute temperature.